Good evening. So, do you have any doubts from week 6 lectures? Good evening, everyone. Let's wait for a couple of more minutes and then we'll start. Meanwhile, you can ask me if you have any doubts. Okay, so let's get started. Good evening, everyone. This is the week 6 live session of the course Basic Environmental Engineering and Pollution Abatement. And I'm Niketa. I'm a PhD scholar at IIT Madras. And today we will be seeing a brief of certain topics that you have already watched in the lectures. And then we will be solving some multiple choice questions. If you have any doubts, you can ask me in between. Okay, so let's start. So, in this week's lectures, we have seen some treatment processes for mainly water and wastewater. So it includes primary, secondary, and tertiary treatment processes. So we will see them one by one. So before we start, can you tell me what are the various sources of drinking water? Where do we get our drinking water from? answers. So there can be many sources, for example, rivers, lakes, etc. And all of these come under the term surface water. Why? Because they are on the surface of the earth. They are above the surface of the earth. So that is why they are called surface water sources. And next we have groundwater. And this can be accessed using wells and pumps. Yes. So, why do we need water treatment? Why do we need water treatment? Why do we need to treat the water that we are about to drink? Why we have to treat it? Sometimes water that we drink may have certain unwanted components called pollutants. So, in order to remove them, we have to do some treatment. Okay. So, generally, for drinking water, the treatment process will be I mean, there will be a primary treatment, and then there will be some preliminary treatment and primary treatment, and then the tertiary treatment. So we will be looking at them. So when you have a water source, first it will be screened. Now screening is done to remove any big particles, floating particles, for example, leaves or plastic bottles and such. So that I mean, they will have some I mean, um, some bars, okay, and they will be inclined, usually at around 60 degrees or so, and they will have some space in between. So, for example, say they have a 6 mm, you have a 6 mm screen. It means that particles greater than 6 mm cannot flow through it. So, like that, we can have maybe one or two screens. So, first we can have a coarse screen and then a fine screen. So, this is done to remove all the floating particles. After screening, the water will be taken for removing any kind of suspended solids and coagulated solids, colloidal solids. So, that will be removed using coagulation and flocculation. Sometimes these processes are sometimes it will be separated, and if there's any space constraint, then both will be combined together. So that is coagulation and flocculation. And after coagulation and flocculation, there will be sedimentation. Essentially, what happens in coagulation and flocculation is all your colloidal particles that remain suspended, they are converted into a coagulated mass, and then this coagulated mass will flocculate together and it will form a even bigger mass. That means like whatever small particles are there, they will get coagulated and turn into some sticky substance. So during flocculation, this colloidal I mean, coagulated substance will come together, and it will turn its weight will be much bigger than what it was initially, and therefore it will be easier for it to settle down. So after settling down, it will be collected and it will be disposed. So that is coagulation and flocculation. We'll see more about this in detail later on. And so the sedimentation is followed by coagulation and flocculation, because after the flocculation, we need a separate tank where the coagulated particles can settle down. So that is why we have sedimentation. And then whatever sludge, whatever sedimented coagulated material is collected, that is called sludge. And this sludge will be disposed. So after sedimentation, the next step is disinfection. Disinfection essentially it kills all microbes, microorganisms, especially bacteria and fungi and viruses, etc. So most of them will be killed during disinfection. And the next process is storage and distribution. So the treated water will be stored in a separate tank, and then based on the usage, the distribution will happen. So in peak hours, the water demand will be high. So that time there will be more release, and in especially in non-peak hours, the water demand will be less, and therefore the release of water will be less. So these are the steps generally followed in a water treatment process. So the first step is screening. Second step is coagulation, flocculation, then sedimentation, and then disinfection, and then finally storage. So now we've already discussed a little bit about screening. So then we will move to coagulation and flocculation. Do you have any questions on this topic? Jay and Sushrita, do you have any questions? No questions, then we move forward.
Is my audio clear?
Yes, ma'am.
Yeah, sorry. All this time I thought my mic was on and I was, I didn't realize that it was off. Okay, sorry for it. So I was giving a brief of all the. Yeah, you have any questions?
No, ma'am.
Okay, so I'll just explain whatever I said. So we have drinking water sources can be divided into two categories: surface water and groundwater sources. So under surface water, we can have rivers, lakes, etc. And under groundwater, it can be harnessed using wells and pumps. So no matter what your drinking water source is, it's better to treat it so that we can remove any pollutants that are present. Um, in order to treat the water, we follow sets of steps. So first of all, we will do screening, and in screening, what we'll have is it'll be like a mesh, like a bar, and it'll have many bars, and the gap between each one will be around 6 mm, so that we can remove any floating particles like leaves or plastics, etc. And usually we will have one or two screens. First, we will have the core screen, which has slightly bigger gaps between the bar, and then we will have the fine screen. Okay. After this, we will do coagulation and flocculation. So coagulation and flocculation is done to remove any dissolved solids and maybe some colloidal solids also. So in this process, we will add some coagulant like alum, and then we will try to flocculate it. So coagulation means turning the suspended particles into big size flocks, and then bringing them together is flocculation. After coagulation and flocculation, we will do sedimentation. So in sedimentation, we will just settle the particles and in a sedimentation tank, and then whatever settled particles are there, it will be collected separately and it will be disposed. So that is the sludge. And after undergoing coagulation, flocculation, and sedimentation, we will do disinfection to kill the microorganisms. And finally, we will store the water and we will distribute it according to the water demand. Okay, so these are the steps generally followed in water treatment process. So now we will look at coagulation and flocculation. So generally, particles will have some kind of a surface charge. So it can be either positive or it can be negative. So what happens is when two particles have the same kind of surface charge, they won't be able to come together because there will be a force of repulsion. So in coagulation, what we do is we add some coagulant like alum. And alum is nothing but Al2SO4, aluminum sulfate, and 14H2O. So this is alum. So this will be added to particles when we add alum to water containing such particles. What happens is the charge will get slightly neutralized. So when the charge gets neutralized, there will be some force of attraction acting on the particles. So the particles will come together and they will form a bigger particle. So this is coagulation. And flocculation is when these big size particles will bond together and they will increase in size and weight, and this process is called flocculation. Okay, so generally these colloids which are formed during coagulation are generally 1 to 100 micrometer in size. And this process can remove turbidity, it can remove color, and sometimes even some suspended solids also. Okay, so can you tell me what is turbidity?
Turbidity, the solution of suspended particles.
Okay.
The solution containing big suspended particles.
Big suspended particles. That's actually turbidity is when you pass light through a solution. The particles in the solution are small and they remain suspended in the solution. And what they do is they just scatter the light in various directions. Okay, so you won't be able to see the light coming out of the solution. When compared to a clear solution which doesn't have any turbidity, the light will just pass through this solution and it will come out. But when you have a turbid solution with suspended particles, then it is not possible for the light to come through in a straight beam. Instead, it will be scattered by the particles. So this scattering of light is turbidity. So there are different kinds of coagulants used. So one example that I've already told is alum. One more is ferric sulfate. And sometimes even some polymers like some polyelectrolytes and so on. Okay, so generally when we add alum to water, it will form a kind of sticky substance. So when water reacts with alum, it gives out 2Al3 plus and 3 sulfate and 14H2O. So this Al3 plus is, this compound will only make the particles coagulate together and stick together. So aluminium 3 plus colloids. This will help in neutralizing the charge. Okay, but one thing is that this process is pH dependent, so you have to maintain a pH of 5.5 to 6.5. If there is any deviation, then the colloids will not form. The coagulation will not take place. So the flocculation is the flocculation is the process where you mix the colloids. Is just mixing the formed colloids so that they form even bigger particles. Okay. So this will be done in 2 stages. First one is flash mixing, which means mixing at a very high speed for a very short duration of time. So this will have a retention time of 1 to 2 minutes. So high speed mixing will be done for 1 to 2 minutes, and this will be followed by flocculation, that is like mixing in a very slow rate. So this will be done for 20 minutes. So the mixing is done in 2 stages. So the first stage is flash mixing, where you just rapidly mix for 1 or 2 minutes, and then this will be followed by flocculation, which is just gentle mixing. Which is done for around 20 minutes. And after this, the water will be allowed to clarify. Clarify meaning that all the solids will settle down, and whatever clear liquid is there on top, that will be transferred to another tank. So this will be done for at least 3 hours. So the sedimentation will be done in tanks known as clarifiers. So it's just rapid mixing. So rapid mixing helps in breaking the charge. 1 second. So rapid mixing helps in neutralizing the charge, and this will be followed by flocculation, which will help in bringing the neutralized particles together, forming flocks together, and this will be followed by sedimentation, where all the flocks will settle down. So rapid mixing will help in neutralizing the particles. Any questions so far?
Ma'am, what is the binding force for flocculation? Charges are already neutralized, then how they
Yeah,
are?
but yeah. So the charge is not completely neutralized. There will be still some surface charge will be there. Okay.
Okay.
Yeah. So it's not completely neutralized, and there will be a double layer will form. So it will have positive charge outside, and inside there will be oppositely charged layer will be there. So during neutralization, only one layer will be neutralized. So the other inner layer will still have some charge.
Okay.
Okay, so then we have seen screening and coagulation. So then let's come to sedimentation or settling. So settling is done to remove any heavy particles which are still present. So in coagulation, we'll remove all the suspended particles, but there could be even more smaller particles which are not settling down. So in order for that, we have to give a tank for settling. So this will be done in a settling basin, and this is based on the Stokes law. Okay, so do you know what is Stokes law? What is the expression for Stokes law? What is the expression for Stokes law? Okay, can you at least tell me where is Stokes law applicable? Where is Stokes law used?
It is used for laminar flows.
Laminar flow.
Yeah, flow of liquid in laminar manner. Laminar flows.
Okay, but I was asking in the context of settling. So when we talk about particle settling, it generally follows Stokes law, and it's given by this expression. So when you have, do you have any other questions? So generally, when you have a particle that is supposed to settle down, so because of its own weight, there will be the force of gravity which is acting downwards, and then there is also the buoyant force. So the velocity of this particle will depend on the balance of these forces. So this balanced or the velocity of the particle at equilibrium is called the settling velocity or Vs. So this is given by this expression where g is the gravitational constant. Rho s is the density of the solid particle. And rho is the density of the fluid in which the particle is settling down. And d here is the particle diameter. And mu is the dynamic viscosity. Okay. So when we have settling velocities, basically it will act downwards. So there will be the buoyant force which is acting upwards and the gravitational force which is acting downwards. So ultimately what happens, like when you have subtract the gravitational force from the buoyant force, and if your gravitational force is going to be higher than the buoyant force, then the particle will settle down, and this downward velocity is what is settling velocity. So sometimes like when we make the water flow inside the tank, it will have its own flow velocity which is acting horizontally. So the particle will also tend to move in a horizontal direction outwards. So this is called the overflow velocity, and it will tend to move upwards and sidewards, that is away from the direction of gravity. And this upward velocity is called the overflow velocity. So this overflow velocity is given by the expression Q by AS, where Q is the flow rate at which the water is centering. So that is Q, and this is given in terms of meter cube per second. And AS is the cross-sectional area. Okay. So next we will be going to filtration. So can someone tell me what is filtration?
In simple way, filtration is a process of removal unwanted or impurities or anything from the drinking water in a general term.
Okay, but unwanted can mean like particles of any size, right? Sometimes even dissolved particles. Can you remove dissolved particles using filtration?
No, it is not possible.
Yes. So filtration is basically a separation process where you have like you can have any mesh or maybe any cloth or something which has a specific pore size. So if you have particles which are bigger than this pore, then that will be retained by the filter. So this process will separate bigger particles and particles that are bigger than the pore. And there are many types of filters. Like sometimes you can have single media or dual media. What this means is you can have just one medium, for example, just sand, or you can have sand plus gravel, etc. Okay. So similarly, like how we saw for settling, here also we will have something called a loading rate, which is the rate at which the water is coming into the filter. So this loading rate is given as VA. So this is equal to the flow rate divided by the cross sectional area, and here the cross sectional area is this, like whatever. If this is a rectangle, then accordingly you have to calculate the cross sectional area. So if you have some cylindrical tank, then the cross sectional area will be, I mean, the shape will be circular. So accordingly, you have to use the formula and you have to calculate this. So the units for this loading rate, or this is also known as phase velocity. The units are in meter cube per day, meter square. So sometimes what happens is when we have water that is highly turbid, imagine you have a filter like this with this pore. So if you have water with high turbidity, then the filter pores could get clogged by the particles, colloidal particles. So in order to remove them, so generally we will do some procedure called backwashing, where whatever filter after filtration, generally the pores will slightly be clogged. So in order to free the pores and remove these particles, we will do something called backwashing. So backwashing is nothing but you just apply a high force, high pressure water in the reverse direction. Suppose you have a filter like this. So from the bottom, we will apply a high force of water, so that whatever particles are getting clogged, they will just come up and they will be removed. So this backwashing needs to be done once in every 10 to 15 days. So generally, there are two types of filters. Can you tell me what are the two types of filters which are commonly used? I'm not talking about advanced filters, just the filters that we use in a water treatment plant. Okay. So we can have slow sand filters and rapid sand filters. So in slow sand filters, we only use the force of gravity, meaning that you will have a filter bed with sand, and the water will be allowed to pass through the pores of the sand um, just by the force of gravity. So, and the water will be collected, filtered water will be collected at the bottom. Whereas when you have rapid sand filters, what we do is the pores will be slightly big when compared to sand filters. Sorry, the pores are almost the same size, but the difference in between slow sand and rapid sand filters is that there will be some, apart from the force of gravity, we will also apply some external force like some kind of a pressure or vacuum, so that the water gets sucked inside the media and filtered water will come out. So here we have the force of gravity and the pressure force. So the reason between why it is called a rapid sand filter is because the filtration process takes much less time when compared to that in slow sand filters. So that is why it's called, since the filtration is done rapidly, that's why it's called a rapid sand filter. Okay. Any questions so far? Okay, if there are no questions, I'll
No,
move
ma'am.
ahead. Yeah. You had a question?
No, ma'am.
Okay. An exchange. So this process is generally done to remove hardness. So can you tell me what kind of ions will cause hardness in water? What kind of salts will cause hardness?
Ma'am, carbonates and bicarbonates.
Of
Sodium, magnesium, these chlorides.
so carbonates and bicarbonates of sorry, not sodium.
Calcium carbonate.
Yeah, calcium and magnesium. So carbonates, bicarbonates, and even sulfates of calcium and magnesium will cause hardness in water. So can you tell me what is temporary hardness? How to remove temporary hardness?
Just boiling them.
Yeah. So when we boil, what happens? The salts will form a precipitate, and they will settle down, and we can just decant the solution. But when we have something called when we have some other salts like sulfates or chlorides, then we cannot use boiling method to remove the hardness, and then we have to use some other processes. So to remove permanent hardness, we will do ion exchange. So in ion exchange, what happens is you have a resin. So this resin is made up of sodium. So you have Na plus ions in them. So when we make water flow through this resin, water which contains calcium and magnesium salts. So when it comes out of the resin, the sodium present in the salt will replace the calcium. So the sodium will replace the calcium, and whatever if you have maybe calcium sulfate, that will react with the resin, and then we will get sodium sulfate instead. So the water will be free from the calcium salt. The water will be free from the calcium ion, and this calcium ion will get deposited on the resin instead of sodium. So when we, after a point of time, what happens is the resin will be completely removed of sodium ions, and it will be only having calcium ions present. So in that case, we will go for some regeneration or recharging. So recharging is done using a solution of brine. So brine is nothing but salt, like maybe NaCl in water. So this NaCl solution will be allowed to pass through this resin. So after some time, whatever calcium salts are there, that will be coming down, and that will be removed. And again the resin will be having sodium. So this can be done maybe after a certain period of time to ensure that the resin is working in good condition. Okay. So next we will see about reverse osmosis. So reverse osmosis is nothing but applying some high pressure pump. Applying high pressure to filter the solution. So reverse osmosis is being used widely in many homes. So it's a very common process these days. Okay. So we've seen filtration. So then we will move to the next step, which is disinfection. So, can you list out various disinfectants that are present, that are being used widely? What is the most commonly used disinfectant?
Chlorine.
Yeah. So the process of using chlorine to remove microbes is called chlorination. So during chlorination, the chlorine will react with water to produce a hypochlorite compound, and so this here is the disinfecting agent. So when we make HOCl react with microbes, then it will lead to the death of microbes. So next, can you tell me the next most commonly used disinfecting agent?
Ma'am, is that hypochlorous acid?
No, that will see. This is HOCl will come under chlorination.
Okay, ma'am.
Yeah. So the other most commonly used disinfecting agent is ozone. So this is a process. This is done in a process called ozonation. So the advantage of ozonation is that during chlorination we will have a lot of. So this HOCl will sometimes react with organics present in the water. Usually, it is we can observe this when we go for wastewater treatment. So in wastewater treatment, the outlet water may have some organics also after the secondary treatment process. So those organics will react with hypochlorous acid, and this will produce some byproducts. So the organics will get incompletely oxidized. They will undergo incomplete oxidation. And they will form byproducts. So these byproducts are highly toxic, and they are undesirable, and therefore they have to be removed. So when you go for ozonation, you will not find this happening because when you use chlorination, the chlorine will be in that water, it will stay in the water, and it will keep on reacting. After killing all the microbes, it will continue to react with the organics. Whereas in ozonation, it is done only for a brief period of time. So it will kill only the microbes. It won't it won't react with the organics. So there will be no harmful byproducts which are forming in ozonation. And ozonation, it will also not have any odor. Sometimes when we use chlorine in water, it will produce some kind of odor. So that's because of the, I mean, chlorine gas will have some smell. So because of that, and sometimes during the organics will undergo oxidation. So that will also contribute to odor. But when we go for ozonation, there will be no odor, and it also removes taste and color. Okay. So till now we have seen the treatment processes which are used for surface water. So we saw screening, coagulation, flocculation, sedimentation or settling, and then disinfection. So now we will see the treatment processes for groundwater. So generally, what kind of pollutants are found in groundwater?
Arsenic,
Yeah,
fluoride.
heavy metals,
Yes, ma'am.
fluorides. Okay.
Some are
Yeah,
Some area uranium also.
uranium. Yeah,
residues, pesticide residues.
minerals also.
Yes, ma'am.
Yeah. Sometimes when there is some kind of contamination from nearby fields, agricultural fields, there will be pesticides for sure. And these days you have a lot of emerging contaminants, so they can also be found in groundwater. So other than this, we can also have pathogen contamination. So when compared to surface water, in groundwater you will have slightly different pollutants. So we have to follow extra steps to treat groundwater, because in surface water you will have a lot of debris and leaves and organic materials will be more, whereas in groundwater you will have a lot of heavy metals, and because there is the water will directly come in contact with mineral containing rocks, and sometimes when we some industries will pollute and they'll just dump their waste on the ground, so that will if the industrial effluent has any heavy metals, so that will leach into the groundwater and it will contaminate it. So in order to treat this we need some special kind of treatments. So one of them is adsorption with alumina. Now, instead of alumina, you can also have activated carbon. And then coagulation or electrocoagulation.
Ma'am, what is the meaning of activated carbon? Is it special carbon or some treatment is being done?
Activated carbon.
Yeah.
Are you asking what is activated carbon?
Yeah. What is the activated carbon? Is it a normal carbon or some special type of carbon?
See, generally carbon will be, it will not have many pores as such, okay? But when we subject carbon to high temperatures, then what happens is it will, almost at 1000 degrees Celsius or so, what happens is the carbon will form some pores on the surface, okay? So this happens during charring. So then something with something which some organic substance which contains carbon is subjected to a high temperature like around 1000 degrees, maybe at an inert atmosphere. then it will form something called activated carbon. And activated carbon especially is known for its pores on the surface. So compared to regular carbon, it will have more pores, and that's why the surface area of activated carbon will be higher. So when you have something which is poreless totally, then the surface area is only whatever whatever shape is that particle has. Accordingly, the surface area will be there. But when you have something which is porous, sorry. So when you have something which is porous, then the surface area will be whatever you have existing on the surface plus the pore area, whatever area is here. So that will also come into consideration. So the particles can settle either here or inside the pores. So it is a way of increasing the surface area of the carbon. So that is why for adsorption we use activated carbon, because adsorption is a surface process. Absorption is a surface phenomenon. So when you have something like activated carbon, your surface area is increased, so it will act as a good adsorbent. Is that clear?
Yes, ma'am. Yeah.
Okay. So now So now we have seen water treatment processes. So then we will move on to treatment of wastewater. First we will see about the treatment of domestic wastewater and then industrial wastewater. So domestic wastewater can be treated in two ways. The first one is on-site treatment. So you must have heard of this term called septic tank. So previously, around some 30-40 years back, this technique was used in many places, especially houses. Houses will have, especially independent houses, they will have a separate tank in the backyard which will collect all the waste, and that tank will be called as a septic tank. So why it is called as a septic tank is because the waste will undergo anaerobic process or anaerobic digestion. So that is why it was called a septic tank, and usually it will be like this. So it will be like a pit, and we have this inlet here, and in between there will be a wall, a baffle wall. So once the water comes to this level, then it will be cleaned out because there will be sludge. So the water will be separated here, and usually there is no air. So in the absence of oxygen, the water will undergo anaerobic. It will be undergoing anaerobic digestion by the bacteria, and it will form sludge. So the remaining water will come out of the tank, and it will be collected separately. So I'm sure most of you would have heard of septic tank. So it is a type of on-site treatment. And usually it will also have a vent for removing gases. Usually gases like methane will form, CO2 will form, even SO2 will form. So these gases are they come out after anaerobic processes, and they will be vented out separately. I mean, the gases will collect at the top, and so they can easily be vented out when we provide a outlet like this. Okay. Now we've seen how wastewater can be treated on site, but generally this is not preferred because it's anaerobic process, and there are a lot of problems associated with septic tanks. Sometimes there will be some clogging or some issues that are happening, which requires us to go inside and check it, and it's not safe to enter this septic tank because it has a lot of harmful gases like methane. So that is why these days people are not preferring to use a septic tank. Instead, we are going for centralized treatment where domestic wastewater from each household is collected, and it is supplied to centralized wastewater treatment plant. So all the wastewater coming from various households are collected together and they are treated together. So this will minimize the cost, and it will also reduce the side effects of septic tank. Okay, generally what happens in a centralized wastewater treatment or municipal wastewater treatment plant is that raw sewage will be collected and it will be passed through screens. So just like we had screening for water treatment, here also we will have screens, and here also we can have coarse and fine screens. Once screening is done, it will be passed to a grid chamber, and after grid chamber it will come to equalization tank. So these three processes together are called pre-treatment processes. This will be followed by primary settling. And then we will go for secondary treatment. So generally we use biological treatment processes. And after biological treatment it will undergo settling again. So this time the settling is called secondary settling tank. After secondary settling, we will do some tertiary treatment like disinfection or filtration, and then whatever treated water is coming out, that will be either these days it is it will be routed off to some rivers, or it will be sent to some lakes. So based on whatever resources are available, so accordingly the wastewater will be disposed. Treated wastewater will be disposed. These days, since we are looking at zero liquid discharge, there is also instead of disposing it in rivers and lakes, the treated wastewater is also used for purposes like gardening and toilet flushing and so on. So yeah, that also happens after tertiary treatment. Okay, generally in primary settling, almost 35% of your BOD will be removed, and so this primary settling is primary treatment. And biological treatment combined with secondary settling will come under secondary treatment process. So here almost 85% of BOD will be removed. And in tertiary treatment, more than 95% of BOD removed. Okay. So now we will see one by one. So we've already seen about screening. So when we compare the screening done in water treatment to that in wastewater treatment, here the number of particles that are required to be removed will be higher, because this will have some sometimes it will have some solid waste also in some places. So this could be some large objects or solids, and once the objects are removed, they will be stored in a hopper. And the stored material will be cleaned either mechanically or manually. These days, you even have you can even operate bar racks like conveyor belts. So continuously you have a conveyor belt which is running. So wastewater will come, and whatever solids are there, it will get deposited here, and it will just move, and it will come here, and it will get thrown out, and it will be collected here. So this is also possible. Okay. Then we have grit chambers. So can you tell me what is grit? What is grit? Okay. Grit includes sand, silt, and even pebbles, small pebbles. So mostly these particles are heavier than your organic solids. So these need to be collected, because if we don't remove sand, silt, and pebbles, what happens is when we go for further processing of when we go to the next procedure of secondary treatment and then tertiary treatment, when water flows through pumps or when water flows through some kind of a pipeline, it can lead to corrosion. When we have water pumps, etc. So sometimes what happens is, because of the presence of sand and silt, they get easily corroded, and even the pipes could get corroded. Joints, especially the joints between pipes, they can get easily abraded. So in order to prevent all that, we have to remove these particles before continuing the treatment. Okay. So after grit chamber, we will have something called an equalization tank. So generally, equalization tank is sometimes given, and sometimes it is people just don't give an equalization tank. Instead, they directly go for primary settling. Okay, and because in equalization tank we just mix the solids. Sorry, mix the wastewater. And why this is necessary is because you sometimes not sometimes, like usually what happens during the peak hours, that is during mornings and evenings, the wastewater generated will be high, and during afternoons the domestic wastewater that is released from households is comparatively lesser. So what happens is when we have a sewage treatment plant that is running for a given capacity, so when we have a very low flow, when we have very low flow, then the equipments that are inside the sewage treatment plant will not be able to function properly to their full capacity, because when you have 100 kiloliter per day capacity plant and you have only 5 KLD of wastewater coming, then it's highly it's very difficult to treat this 5 KLD water, because your plant has been designed for a bigger capacity. So all the tanks or whatever motors and all will, I mean, they won't be as effective. So that is why it is important to maintain the flow rate. So if it is a 100 KLD plant, then this 100 KLD flow rate has to be maintained. So that is why when you have low flow and during the afternoons, and when you have high flow during the mornings and evenings, you need a tank kind of thing where you can ensure that where you collect all the wastewater, and you just ensure that that the flow rate is maintained. So sometimes when there is no flow, or maybe there is less flow, the equalization tank will collect the wastewater that time, and then it will store it, and then slowly it'll it'll whatever low flow is coming, so it will regulate the flow accordingly, and then it will send to the next treatment process, so that you don't have any cases of like there is something called flash loading, where unexpectedly the treatment plant will have a high load, and after that there will be no flow at all. So in order to avoid that, we will have an equalization tank to ensure that the flow rate is maintained properly. So when there are high flows, then it will reduce the flow at the outlet, and when there are low flows, then accordingly it will collect the water, wastewater, and then it will let it out. So that the water, the capacity of the sewage treatment plant is maintained properly. Sometimes when there are when the loading is very high, for example, you have a 100 KLD treatment plant, and you have say around 105 KLD is the flow rate of the water coming in. So then this tank will be designed in such a way that only 100 KLD water will come out. And when you have immediately after some 2-3 hours, when the flow rate reduces, so this same flow rate will be 100 KLD will be maintained, so that whatever incoming water is there, and also whatever water is existing inside the equalization tank, so they will be mixed together, and then they will be sent at the same flow rate. One more advantage of using an equalization tank is it prevents the wastewater from turning septic. So septic, one more word for this is anaerobic condition. So you just keep mixing it and aerating it so that it doesn't, when you have a high flow rate, incoming flow rate is very high. So when you store that wastewater, when we keep mixing it and aerating it, it ensures that the anaerobic condition does not develop. Okay. So then the next one is the primary settling tank. Okay, so the grid chamber will remove all the inorganic particles that are heavier than the organic solids. So in primary settling tank, we'll remove organics which are slightly heavier and which can settle down. So here we will provide longer settling time when compared to longer retention time when compared to a grid chamber. So here we can remove settleable solids. And even the floating substances can be removed. So it will be like it will be in the form of a tank, and the tank will have a floating arm at the top. So this will just skim through the solution, skim through the wastewater, and it will ensure that whatever oil, grease, fats, etc. are there, they'll usually come to the top, and so the soil, grease, etc. will be removed as the arm will rotate. So in case you have a circular tank, the arm will be like this. So it will rotate and it will remove all the scum, grease, etc. whatever is there on the surface, and it will be made to come out. So settleable solids also includes solids that can be coagulated. Okay. Like how we saw in water treatment, here also the settling is governed by Stokes' law, and there are some other factors also. For example, the particle density, the size of the particle, temperature, now temperature, because when you have something, temperature affects the viscosity, so that's why temperature is also important. Turbulence. So turbulence will generally hinder the settling of particles. When it is highly turbulent, then settling will be very difficult. Then stability. Bottom score. This means how frequently we are removing the settled substance at the bottom. And then your flocculation. If the particles are forming flocks immediately, then the removal will be better. But if the flock formation is slow, then accordingly the process will also take time. Now there are different types of settling. So first we have type 1 settling. Can you tell me what is the other name for type 1 settling? What is another name for type 1 settling? Okay, type 1 settling is also called discrete settling. So here we assume that all particles are discrete and all particles are settling down at the same I mean all particles which are in the same depth. For example, here I'm taking this depth as h. So all particles which are at a height h from the bottom are assumed to settle down at the same time.
So the second type of settling is called type 2 settling.
So
Can you
the
tell me
second
what is an
type of
alternative name
settling
for
is called
type 2
type 2
settling?
settling. So can you tell me what is an alternative name for type 2
Continuous.
settling?
Continuous.
Continuous.
No, this is not a function,
No, this is not a
Niveta. This is
function, Niveta. What is
Okay,
type 2
ma'am. Okay,
settling?
yeah.
ma'am.
Fluctuant settling. Fluctuous.
Huh?
So yeah,
Okay.
flocculent
So yeah,
settling.
flocculent settling.
So
So
what is flocculent settling?
what is
We just saw
flocculent
that in
settling?
discrete settling, all the
We
particles
just
are
saw that in
discrete.
discrete
That
settling, all
means
the
there
particles
is
are discrete.
no
That means there is
agglomeration.
no
All the particles
agglomeration.
are at distance
All the
from each
particles
other.
are at
So
distance from each other. So
like there is no contact between two
like there is
particles.
no contact between
But
two particles.
in flocculent
But
settling,
in
the
flocculent
particles
settling,
are forming flocks.
the
So they come in
particles
contact
are
with each other
forming flocks.
and
So they come in
they
contact
settle
with
down
each other
after
and
forming a flock.
they settle down
So
after
can
forming
you
a
tell
flock.
me what happens to
So
the velocity of
can
the
you tell
particle
me what
in
happens
discrete settling
to the
and
velocity of
flocculent
the
settling,
particle in discrete settling and
which will take
flocculent
less
settling,
time?
which will take less time?
Type 2.
Yeah. Why is that?
Yeah. Why is that?
Particles become heavier.
Yeah.
No?
So
Yeah. So
when the particles are
when
heavier,
the particles are
so the
heavier,
time required for
so the time
settling will
required for
reduce.
settling will
And
reduce,
that happens
and that
because the
happens
velocity of the
because the
particles
velocity
will
of the
increase.
particles will increase.
Okay, so
Okay, so
this will
this will
increase
increase
along with the depth.
along with the depth.
So
So
just
just
making the
making the
tank a
tank a
little
little
bigger.
bigger. So imagine you have particles, okay,
which
which
are
are
only
only
beginning to
beginning to
flocculate.
flocculate.
So
So
at
at
this
this
at
at
the
the
top,
top, you may not have so many flocculated particles, but as we move slightly down with time, as they come to as they settle down, so these two particles will come together, and similarly these two particles will come together and they will form a bigger particle. So after some times, these two particles will come together and they will form an even bigger particle, right? So the velocity of the particles at this height will be slightly lesser. Okay, let's call it v1, and at this stage it will be v2, and at this stage let's call it v3. So here, if you see, v3 is going to be higher than v2, which is going to be higher than v1. That's because when we reach this stage, the flocks are quite big and heavy, and that's why their velocity will be low. I mean, very high when they settle down. But when compared to the top layer, the particles will not have such a high velocity. So that's why here in flocculent settling, the velocity of the particles will increase as a function of depth. As we go downwards, the velocity of the particle that is settling will increase. It will be slow here and then it will be slightly faster. And when it comes here, it will be slightly even more faster. Okay. Okay, so can you tell me what is type 3 settling? What is another name for type 3 settling?
Is hindered settling.
Yeah. So here, so here what happens is when sometimes what happens, the particles, they will be because of the presence of other particles, they will not be allowed to settle down. So when you have when you have many particles here, so the particles at the top will not be allowed to settle down at the bottom because there are other particles which are hindering their settling. So this is called hindered settling. And then we have the type 4 settling. So can you tell me the name of type 4 settling?
It is compressed settling.
Yeah, compressed settling. So another name for this is zone settling. So when you have high concentration of particles, so when you have many particles, when the concentration of particles are higher, so at the bottom you will have one zone. At the top, some other particles will be there. They will also come down and settle, and they will also come in layers. So when you have high concentration of particles, the particles will settle down in layers, and the bottommost layer will be compressed. So since there are many other layers at the top, so the weight of all these layers will add up and it will compress the bottommost layer. So this is called compression settling. Okay. So when we are discussing about settling and sedimentation, so we saw that there are two kinds of velocities. One is the settling velocity and the other one is the outflow velocity, which is outwards. So when this outward velocity, which is in a different direction, which is against the settling, so when this velocity is greater than your critical velocity, then whatever settled solids are there at the bottom, even they will be removed and they will be coming out of the tank. So what this means is that you should maintain a constant velocity which should not be higher than the critical velocity, because when you have a very high velocity, what happens is whatever settled solids are there in the bottom, they are because of the high velocity, they will be moved from their position, and again suspension will be created here. So, and then these particles will be coming out of the outlet. So that is why when you have a sedimentation tank, the velocity of overflow velocity should be such that it is less than the critical velocity. If it goes beyond, if V becomes greater than Vc, then the settled particles will also get resuspended and it will come out of the tank. So this condition has to be maintained. And so this critical velocity is given as square root of 8 into beta by f into g s minus 1 into d. So here beta is a constant and f is the friction factor. So usually it is taken as 0.03 and S is the specific gravity. Which is about 2.65 and D is the particle diameter. Okay. So now we will come to secondary treatment. So can you tell me what are the two different types of biological treatment that is usually used? Two types of biological treatment processes based on oxygen.
Anaerobic and one is anaerobic.
Aerobic and anaerobic.
Yeah. Good. Okay, can you tell me what is the difference between the two?
One takes place, first one without in presence of oxygen, second one not in presence of oxygen. Second one.
Okay. And anaerobic in the absence of oxygen. So aerobic processes are those that take place in the presence of oxygen, and anaerobic processes take place in the absence of oxygen. So instead of, it's not completely in the absence of oxygen. Instead of oxygen, the microbes will find some other oxidant to utilize for their respiration. So in aerobic treatment, generally the organics, which for example 1206, I'm just writing the formula for glucose. So generally when we go for aerobic treatment, glucose in the presence of oxygen and microbes will be converted to carbon dioxide and water. Okay. So generally in aerobic treatment, CO2 and water will be produced, whereas in anaerobic process, the products are generally methane, water. Sometimes if the organics contains sulfur, then sulfur dioxide will also be produced. So these are the differences. Also carbon dioxide will also be produced. But the major difference between aerobic and anaerobic is that in anaerobic processes, methane gas will be produced. In aerobic, it will not be produced. And these two processes are taking place in the present by using microorganisms or bacteria. But we also have processes where living organisms are used, like plants. So one of them is phytoremediation. which is basically just using plants to treat the wastewater. So the plants, when we pour some wastewater into certain species of plants, they will metabolize the wastes and they will grow with the help of those metabolized waste. And the water which is coming out of them will be, once the organics are used by the plants for their metabolism, the water will be free of those organics and contaminants. Okay. So, when we have microbial treatment systems, there can be two types of microbial growth. Can you tell me the different types of microbial growth? Okay, you can have suspended growth. Suspended growth means that you have wastewater and your microbes are suspended, and they are also supplied with oxygen. So we use some aerators and we supply oxygen, and the microbes are in suspension, and while in suspension, they degrade the organic matter. Okay, so examples can be activated sludge process, which is also known as ASB in short, and stabilization ponds. And even anaerobic digestion. So all these are examples where the microbes remain in suspension and they degrade the organics present in the wastewater. So the second type is attached growth. So attached growth, like the name suggests, you have a media. For example, some kind of a ring or a shell over which your microbes will grow. So imagine this is completely covered in microbes, and when this media containing the microbes comes in contact with wastewater, so the wastewater coming out of this, the wastewater will, the organics present in the wastewater will get degraded by the bacteria present on the surface of this media, and whatever wastewater is passing through it will be having lesser organics than the inlet water. So example of this is trickling filter. And rotating biological contactor or RBC. So in an RBC, you will have a rotator like this, and this will be suspended in a tank containing wastewater, and this rotator will be rotating at a very slow motion. So I'm showing the side view here. suppose your rotator is like this. This is the central axis, and you have wastewater. So when it keeps rotating, so this is the portion that is not dipped in the wastewater, and this is the portion that is dipped in wastewater. So when the rotator rotates, it will get dipped in the wastewater first, and then it will come up, and then it will go down again. So every time it goes down, it will take some of the organics and bacteria that is present, and when it comes up, it will get the bacteria will get oxygen. So the bacteria will degrade the organics. Again, when it goes down, the dead bacterial cells and everything will settle at the bottom, and again it will take some more organics, and the cycle will keep continuing. Okay, so after a point, there will be a layer of dead cells or bacteria which are formed on this RBC. So what happens is, after some time, this layer also, it will come off. It will start coming off in a process known as sloughing. So even the layer of dead cells, dead bacterial cells, so they will also they form a thick layer, and this layer will be it will start to because of because of lack of frictional forces to bind the particles together, so it will just start coming off one by one, and this process is called sloughing. Sometimes we can even have hybrid processes which combine both attached growth as well as suspended growth. Okay, then we have lagoons. So in lagoons, both bacteria and algae will degrade. So imagine this is the lagoon. So your raw waste is entering here, and we have algae. So the algae will utilize the carbon dioxide and ammonia. It will mainly use the carbon dioxide, but also ammonia will be produced. And this carbon dioxide will be produced because of the degradation of organics by bacteria. So algae will use that CO2, and instead it will give out oxygen, which will be used by the bacteria to degrade whatever organics which are coming with the wastewater. So as bacteria will degrade the wastewater, it will also die, and whatever dead cells are there, dead bacterial cells, they will be collected at the bottom, and this will be called as sludge. So at the surface, gas exchange will happen. Both CO2 and oxygen will be continuously coming in and going out of the lagoon. And at the top layer, it will be aerobic because it is on the surface, and it is in contact with oxygen, so it will be aerobic. But when it comes to the bottom, it will sometimes be anaerobic. That depends on the depth of the lagoon. If it is highly shallow, then only aerobic will be there. If it is very deep, then as we go to the bottom, the oxygen levels will drop. So that is why anaerobic conditions will be developing at the bottom. And in this sludge layer, completely anaerobic conditions will be there. So whatever organics are coming and directly settling here, they will undergo anaerobic digestion or anaerobic process. So advantages of this are that lagoons are low cost, they don't require much maintenance, and the design is also very simple. So there are no mechanical parts or anything, no pumps or pipes or anything. So maintenance is very low. Maintenance cost is very low, and the design is also very simple. Okay, coming to aerobic digestion. So there are some requirements for aerobic processes, like you should have a high concentration of microbes. And high concentration of O2 or oxygen. And you should also have favorable conditions of temperature, pH, nutrients, etc. And also there should be no toxins. So if there are any toxins, then the bacteria will die and the process cannot take place. So then activated sludge process. So in this process, the bacteria along with organics are agitated and the organics are oxidized. So now we will see about anaerobic digestion. One example of anaerobic digestion is UASB, which is also called upflow anaerobic sludge blanket. So what happens in a USB reactor is, we have the reactor here, and this is the gas vent for removing the gases that are produced during anaerobic digestion. So the inlet is towards the bottom. So what happens is wastewater comes up, and here it will undergo digestion. So after digestion, the heavier particles will come and settle at the bottom, and they will form a layer called a blanket. So generally, after some time, when the blanket forms, the wastewater will be flowing through the blanket, and it will come here and it will get digested. Again, the bacterial dead cells will come down and settle down, and it will form a blanket. So this blanket will keep increasing in height. Okay, then we have we were discussing about attached growth processes, and there can be different types of attached growth processes. One of them is trickling filter. The other one is rotating biological contactor. One of them is trickling filter, and other than that, we can have within trickling filters, we can have fluidized bed, packed bed, and there is even rotating biological contactor. So these two are the most commonly used. So when we have biofilters, the microbes will go through certain stages. The first stage is attachment, where the microbe will get attached to the medium. So imagine this is a microbial cell, so it will come and it will attach here. So this is attachment, and then the growth stage. The microbe will degrade the organics and it will utilize the organics for its own growth. So it will grow and it will multiply. So the microbial population will increase. And then decay and detachment. So once the microbes die, they will form a sludge layer, and this layer also will get detached from the media. So imagine this is the media, and you have this layer of dead cells over it. So over time, what happens is the top most portion of this layer, it will not have any contact with the media. So when we do some backwashing, when we pass water or air at a very high speed, when we pass air or water at a very high speed, what happens is this layer will come off. And this is like what I already said, this process is called sloughing. Okay. So, do you have any questions?
Ma'am, sludge removal is required in lagoon also, na? Otherwise, depth will become
Yes, yes.
shallow after,
Yeah.
shallow after some time.
Yeah, dredging will be done.
Okay. Okay, right.
From time to time, once the depth is increased, then dredging will be done. So it will be done to remove the sludge at the bottom. Any other questions? Okay, if there are no questions, then we'll proceed to the question and answer session. So, okay, first question. Which of the following is the flow rate for rapid sand filters? Any answers? Which is the flow rate for rapid sand filters? So for rapid sand filter, the flow rate will be high or low? So in rapid sand filter, the filter bed, water will be passing through the filter bed by the force of gravity also, and also because a negative pressure will be applied to suck the water. So the force that is acting on the water will be higher. It will be a combination of both gravitational force and the pressure force. Sorry, the suction force. So that's why the filtration will be rapid and the flow rate will also be high. So which do you think will be the flow rate? Okay, the correct answer is greater than equal to 120 milligram meter cube per meter per day per meter square. Okay, the next question. Which of the following is a cheap technique to remove arsenic from groundwater? Any answers?
Ion exchange.
No. We saw that ion exchange is used for removing which type of pollutant? Ion exchange is used for removing what? So ion exchange is mainly used for removing hardness. Like we saw that calcium 2 plus will be exchanged with
Yes, ma'am. Yes,
sodium.
ma'am.
Yeah. So what do you think is the answer?
Should be clay filters. Should be.
Yeah, yeah, that's right. So clays will sometimes tend to absorb arsenic, so that's why clay filters are used. Okay, the next question is BOD to COD ratio must be higher than dash for efficient biological removal. Can you fill the correct answer? So when you want to use biological treatment, we have to ensure that the waste can be treated by biological treatment. So we have to make sure that whatever waste we have, it is getting oxidized. Can be oxidized using biological treatment.
Ma'am, 0.4.
No. So if we want to ensure that the waste can be oxidized by biological treatment, naturally it means that the BOD should be higher. Okay. So if we want to do biological treatment for wastewater, then we have to ensure that the BOD should be higher than the COD. So the BOD to COD ratio should be in such a way that the organics can be converted into simpler forms using the action of bacteria. So if we want to go for biological treatment, we have to ensure that there should be a good balance between BOD to COD to ensure that the microbes can efficiently degrade the organics. So the correct balance is,
Point C should be C.
yeah. Okay, what is the required MLSS concentration in activated sludge process? So here MLSS is mixed liquor suspended solids. Which is actually the concentration of bacteria. So MLSS refers to the concentration of bacteria. So what should be the concentration in activated sludge process? Should be high or low. So what is activated sludge process? It is where the bacteria are suspended in the wastewater and they are aerated with oxygen so that they can degrade the organics. So if the concentration of bacteria is high, then sufficiently high, then it can degrade the organics effectively. So the correct answer is 3000 to 6000 milligram per liter. Okay, the next question. Which of the following is not a tertiary treatment process? Can you tell me the correct answer?
Trickling filters.
Yeah, correct. Okay, so with this we have come to the end of this session. If you have any questions, let me know. If you don't have any questions, then we'll close the session. Okay, so we'll end the session. Thank you all for joining.